Jen Greiser. I'm the Director of Natural Resources with Cleveland Metroparks, and we are here at the Chagrin River at Jackson Field project here in South Chagrin Reservation. My team and Natural Resources worked with Chagrin River watershed partners to do some stream bank erosion analysis along the Chagrin River. It was really extensive, and that work was able to recruit grant funding from Ohio EPA 319 with matching funding through the Northeast Ohio Regional Sewer District and our Stormwater Management Reimbursement Fund. With that, we kind of have this project sign of the concept plan, and you'll hear a little bit later from our project designers from EnviroScience and Derrick. And I'll kick it over to Chris to talk about the project timeline.
Hi, I'm Chris Trasso. I'm a landscape architect with the Cleveland Metroparks. As Jen had mentioned, construction here began in January, and it's expected to be complete, the main restoration by March, with plantings to take place after that. A lot of the material that's out here was salvaged from the site. Some of the trees, the live willow cuttings, and a lot of the material used for the stream bank restoration is material that's actually on site here. So with that, let's go and learn more about the project.
I'm Julie Bingham with EnviroScience. I was the designer on the project along with our engineers and a lot of our staff at EnviroScience.
Derrick out of Bovina, Mississippi. I was a research hydraulic engineer for 35 years with the Corps of Engineers, and I've got my own company now, River Research and Design Incorporated, so I was brought in to kind of help with bendway weirs and foul wag management and how we could kind of get all of this water that's going to come bounce off that hill, come straight down here, kick over to the other side, get that around this bend, and kind of manage that or control that and slow that down so that we can do all kinds of great vegetation and roughness up on the floodplain benches.
We're about 2 weeks into the project, and there's a lot of activity here going on, but essentially this river had migrated laterally almost 200 feet, so about 2 channel widths. And you can see the mature vegetation on the side there would have been in alignment back close to around 2010, so approximately a decade ago. And what we're trying to do is shift the river back about a channel width over. Part of the design process to figure out where we're going to put this river back was really doing some of that aerial analysis, and we're looking at feasible tie-in points upstream and downstream where the river didn't really depart that much since that time frame. So we're essentially able to connect the meander back into those points of the river. So we're playing with the geometry, not against the geometry. When those rivers get really far laterally, they begin to push a lot of, and they attack specific points on the bank. The point bars will point right to where the erosion is, and we got a lot of lateral migration. It's affecting a lot of bridle trails here and things like that. But more importantly, it's a water quality issue. Dumping a lot of sediment into the banks. The Chagrin River has had a lot of erosion through these areas, so we can come to these more important public places, put back the stream in alignment, fix the point bar, and put a lot more habitat on the bank.
Right in this area, you kind of see how this water's coming down off of this kind of a ridge in the middle of the stream. So that's called a transverse bar. Basically, you're going to look at the slope on this river in this riffle coming from upstream to downstream. What happens is most of the river where it's relatively stable is about 95 to 100 foot wide, from like toe bank to toe bank, right in that range. In here, it's obviously it starts to get wider. It's kind of blown out this bank. Also has a couple holes in the bank on the other side. When it gets wider and the cross-sectional area increases, then the velocity decreases. When the velocity decreases, the river starts to drop out the biggest things that it can carry, which is typically trees, and then the next would be the biggest material that's bed material, either boulders, gravels, cobbles, something like that. So when you look upstream at that bar there, you can see that that's some pretty good sized stuff. So that's what drops out first. And then as it gets wider and wider and slower, then it drops out the next smallest particle. So you'll go from, say, cobbles, gravels, pea gravel, get into coarse sands, medium sands, fine sands, silts, clays. That's called downstream fining, as you look at the size of the particle and they get smaller and smaller and smaller as the cross-sectional area decreases or increases and the velocity decreases. So what happens is, when you think about this, and this is the slope of the bottom of our river, in this area where it starts to get pretty wide suddenly, then that material drops out, so that bed starts to upgrade or come up. So you can see that you're taking slope, the river's taking slope out of this area. So it's decreasing its slope, which is reducing some of its energy, but then it sets up a bar at like a 30 to 40 degree angle. We can see a drop in there, probably about 6 inches or so. And it was aimed right toward this bank. So upstream, it's taking out energy. Transverse bar, energy gets turned kind of sideways, comes in, erodes this bank. So downstream of the transverse bar, it's starting to erode the bank and make that section of the river longer, which also takes slope and energy out of the system. This is probably the trickiest part of the, for me anyway, the trickiest part of the project, where this transverse bar was really redirecting all of the energy into this bank. And we didn't really want to go up here and stabilize, you know, hundreds and hundreds and hundreds of feet of this bank directly with some kind of stone protection or some kind of a, you know, heavier bank protection. So the bendway weirs, the upstream angled, almost underwater sills, they're going to stick up. In the summertime, they'll probably stick up about a foot or less. Relatively, these are longer, the other ones are shorter. But what we wanted to do was key back into the bank, so that's not built, but it'll go back to the, there's a stake. This is a 20-footer.
There's a key right
There. Okay, yeah,
There's the end of the key.
There's our key. So we'll dig a trench in here, and we've got 2 tons per foot of stone that'll tie back in. It'll get covered up, and then we can also vegetate that, so you won't see that. But the main job of that key is to not allow the river to come around to get behind the end of the key and the end of the bendway weir and flow down through the path. So we've got the ends of these weirs out enough that from the end of bendway weir number 1, you always go upstream to downstream. Number 1, we've got 10 in here. Over to the other side, that's 100 foot. Number 2, bendway weir number 2, you can see the end of it. It's a 45-foot long bendway weir. That's 97 foot to the opposite bank. And then number 3 is a third stake. It's also 100 foot from that stake over to the other side. So basically, we're going to take this river that's way wider than it needs to be when you start running your analysis. We're going to narrow it up to that 100 foot, 97 to 100 foot wide, and that will maintain that channel, and it will not allow the river to set up this transverse bar to kick all this energy into this bank through here. We're going to take some of the substrate and put it up against this bank, and typically within these weir fields, the water in here, you can see how dead it is, right? And you can see where the thowag is. But I really like the way this looks. When the water's lower, then it's going to be off the end, but you can see all this dead water in here. You can see dead water upstream. And these things are very, very effective. And even if we have 50 foot of water over the top of that bendway weir, we'll have really low velocities. Even at the surface, it's amazing. Everybody likes to build everything big and rough and tall. The secret is to make it low and smooth. And just, you can't fight it. If you fight it, you're looking at high maintenance or failure. So something that's really like nice side slopes, low, but it's a good roughness component. You can see with our angle, when the water comes in, there's still some coming in, but it's not very, very fast. Goes over the top of the weir, slows down by about 50%, and when it leads, this is the important angle, the downstream angle. You can see that that water goes perpendicular to the angle of the bendway weir. That's why it's angled upstream. Your fast water's off the end. It's probably twice as fast, or maybe even more than the water over the top of the weir, even when you got several foot of water over the top of it. But you can see with that angle that it's kicking that water away from the bank and going toward the center of the stream, and that's where we want it. You know, we're okay with having fast water out there. We don't want the fast water up against a bank, because obviously it was able to overwhelm that bank, remove that material and take it downstream, and you know, you just don't want that much fine sediment within your river system.
You know, having the high velocities next to that kind of low slack water velocity is really nice diversity flow habitat for fish. After you get suckers, a lot of darters, you know, in that deeper water, and by us constraining that thaw wag a little bit and getting it back so it's not so overly wide. We came here before, these riffles were very shallow. And they were not, I would say, ideal habitat for fish. Very fine grained substrates. They were very unstable and immobile. With having the coarser substrates in there that will get in there at that higher velocity, keeping the fines out, better for macroinvertebrates, better for darters, better for suckers, better for a lot of fish species. And then this diversity of habitat offline from that flow, you know, it's almost like having a run and pool habitat right next to each other for a long distance. Really nice habitat.
This gigantic field, that's all cut material that we had to remove for some of the roads and stuff. Most of it's going to be integrated into the river's edge. We're going to dig trenches back into the bank, and probably 1/3 of that will be in the trench. We'll cover that back up so it's going to lock it in. And then all the way across this new floodplain bench, we've got a couple living dike, dead dikes. So when we complete it, we'll dig a trench with the track hoe, and then we'll put a lot of this dead material in there. We'll also put in live poles, sycamore, dogwood, willow. All of those plants, those species will grow from an unrooted cutting. So these will be cuttings that are probably 6 to 8 foot long. So basically it's going to look like a gigantic vegetated tank trap to a degree. And when you get on these floods, it's amazing when that water comes in here and interacts with that trench full of this material. It catches a lot of the debris and it slows it down, and it might drop out 1 inch or 2 of sediment in here. It's so effective on slowing things down, dropping out sediment, killing all that energy, because everything's going to be brand new. Everything, you know, we're trying to get vegetation and grasses and shrubs and trees, trying to get all that started. That roughness will be so effective on, if we get a big flood, we're not going to lose this soil. And it's also going to have an erosion control blanket on it, a straw type of material erosion control blanket. So it'll have direct protection with seed underneath it. But the living dike, dead dikes are really going to kill all the energy in here.
We're in the pool part of the meander. Right around Bendway 3 is where the riffle stops and this pool starts. We started in a run, well into the pool here, and then around the corner, we haven't established yet, but there'll be the riffle crest down there for the next riffle. But in this pool, the base flow is about between 4.5 and 5.5 feet deep, base flow. So we're looking at the kind of the base flow water surface elevation right here. You're looking at pretty much the finished grade base flow width of the pool. And that's sloping down to a bottom width of the pool. It's about 20 foot wide in the deepest part of the pool. And then what you can't see is there's rock on this toe at about a 1.5 to 1 slope that's kind of protecting the toe of this outside bank. We need to use that rock to protect the toe in order for the vegetation to really take off and establish, but also resist that flow, keep the sediment moving through here. We're using all that material to kind of interlock together, all those different sizes. And then lastly, we choke all that stuff together, get rid of those voids and spaces and make a nice cohesive mass with just some of the native material we're either pulling out as part of our excavation or the material we have here right behind us. The river used to be back there 40 or 50 feet away, so we've advanced it forward, remember that 2010 alignment. So we're essentially mining the material that the river's given us, the deposited over that time, and we're flipping it over here onto this side of the river to bring it up to meet these finished grades. Okay, and at the end, we'll have a nice accessible floodplain at proper elevation. It's going to blend into the mature wood line over there. The last thing we haven't really talked about were the living dikes. And so what that is basically at the end of these keys, there'll be a series of these perpendicular trenches that are dug in a finished grade, and those are going to be, we harvested a lot of willow material. We had a really nice group from Cleveland Metroparks, volunteers, who spent a Saturday, and we harvested some willows from a nearby area. We got big 6-foot long posts. So basically there's going to be about 2 foot of that sticking up there, and that's going to help create that day one woody roughness across the floodplain. And also it's going to give us an opportunity to grow those important willow species that are going to sprout throughout this area. We'll also put some pieces of sycamore in here, hopefully they'll grow. And just some branches, just anything that creates roughness as it goes over this flat bench during a flood. If you look at this project in relation to the budget, it's a lot of work here, but one of the things that made it possible was being able to reuse this material. If we had to import this fill, this project would have been double or triple the cost. So the sand and gravel that in these larger rivers, if you can reuse that material, it really becomes cost effective.
We were really fortunate to be able to do this because of a land donation. They actually donated basically the back portion of their property to allow us to have a larger project area.